All right, you're doing very great. So now our question is, let's continue with the Laplace transform for now. Our question is Laplace of 1 plus 6t. How do we go about it? Pause the video and think about how you can attack the question. Right. So we know that Laplace transform is an integral. Okay, as we have seen at the start, that Laplace transform is an integral. This is the definition of the Laplace transform depends on an improper integral, but basically it's an integral. It means that integrals have the property, they can be written as, for example, if we have integral of f, a function, plus or minus g dt, we can write integral f dt plus minus g dt. We can split the integral into two if there is a plus or minus between them. So we can do the same for the Laplace transform. Laplace of f plus minus g, we can write Laplace of f separate plus minus Laplace of g separate. This property is called linear property of the operators. Right. This using this property, our question becomes Laplace of 1 plus 60, Laplace of 1 plus 60, so Laplace of 1 separate and Laplace of 60 separate. And that is Laplace of 1 is 1 over s, 6 goes out, 6 goes out because it's a constant, and then Laplace of t is 1 factorial over s power 1 plus 1, as we saw before, n over n factorial over n plus 1. So n is 1 in this case, power is 1 here, power is 1. So 1 factorial over s power 1 plus 1, that gives 6 over s square. All right. Next question is e power Laplace of e power 2t minus 15 sine 2t. All right. Pause the video and give it a try. Right. Let's see. So once again, we have two terms in the function. This one is separate, there's a minus between, and this one is separate. So we will split our Laplace into two with the minus in between. So we will write Laplace of e power 2t minus Laplace of e power 2t separate for the first one, minus 15 times Laplace of sine 2t for the second one. This one is a simple answer, s minus a, where a is 2, so we get s minus 2. This one, k over, so our k is 2 here, k over s square plus k square, k over s square plus k square. So that becomes 2 over s square plus 2 square. So that will give 2 over s square plus 4. So our answer, this 15 multiplies with this 2 and we get a 30, and that's the answer. Next one is e power minus 2t minus 6. Now our formula e power at, it does not have any constant here. So there is no constant like plus k or minus k, which we can use for minus 6 here, which we have this extra constant here. Our formula will not work as it is for this function. Now we have to make some changes into our function. What changes do you all think we can do? Take a guess. What are the possible answers? Give it a try. Pause the video. Right. We can use a simple fact in algebra which tells us x power m plus n equals x power m multiply x power n. So this rule, basic rule of algebra, we can write e power minus 2t multiply e power minus 6 because base is same. Now e power minus 6, e power minus 6 is constant. It does not have any t in it, so it can go outside. Using which rule? L16. Where is L16? Let's go find L16. L16, here it is. L16. B multiplied with a function as a constant, B can go outside and we can take Laplace of the function. So here, this one, e power minus 6, is a constant. So it's just like Laplace of b f of t is equal to b times Laplace of f of t. So b goes outside. So e raised to minus 6 goes outside. Laplace of e power minus 2t. Now, another important step here is that be careful. There is a minus here. And this minus, along with the formula minus, make a plus. Laplace of e power at has a minus in the formula here. So if a is minus, that will become plus. So the answer for this is e power minus 6 over s plus 2. Right. Next one. This one was the question from the exercise 4.1, question number 12 we have done. So next we are going to do question number 30. Our question is Laplace of e power t plus e power minus t whole square. Now Laplace cannot go inside the square. It can go inside only if the functions are simply in the form this one, f plus minus g, no power. So if the situation is f plus minus g whole square, now we cannot write Laplace of f square plus minus g square. That is wrong. That is wrong. Okay, this is not equal. Right. So now we have to expand the square using a proper formula, which is a plus b whole square, a square plus b square plus 2ab. That's what we do here. So a square gives e power 2t, b square gives e power minus 2t, and 2ab gives 2. Remember, e power minus t square is e power minus 2t, not e power plus 2t. Do not consider this 2 as a square, like we say that minus power becomes positive when we take square. Sorry, minus becomes plus when we take square. This one is x power m whole power n. X multiplies m multiplies n here. So minus t multiply by 2. Okay. When minus t multiply by 2, we get minus 2t, not plus 2t. Second important point is this 2 here. So e power t multiply e power minus t, the ab term, and t minus t becomes 0, e power 0 becomes 1. The rest is more or less simple. So we split the Laplace over addition, L of e power 2t, then plus Laplace of minus 2t, and then Laplace of 2. This one is minus 2. Again, note the plus sign here because there is a minus in the power. A is minus, so we get a plus sign, and then 2 over s. All right, that's all for now about Laplace.